Hey guys, how's it going? Mr. Mitchell here. In this video we're going to look at path difference, so let's get started. So we're going to start by looking at what is meant by path difference. So it says here, interference patterns arise from the fact that waves from different coherent sources travel different distances. This difference is known as the path difference. And before we look at path difference in more detail, it says some new terminology is introduced in this section which you need to be familiar with. So firstly, a maximum is a point of constructive interference. We use the term maxima to describe more than one maximum. A minimum is a point of destructive interference, and we use the term minima to describe more than one minimum. And lastly, the order number m is an integer, i.e. a whole number value, which describes which point on the interference pattern or screen you're dealing with. So in the theory videos that follow for this interference subtopic, we're going to be using these terms a lot: maxima, minima, and order number. It then says, consider waves produced by two coherent wave sources S1 and S2. An interference pattern will be produced on the screen with regions of constructive and destructive interference. Take a point P in the center of the interference pattern as shown below. So here you can see that from the slits S1 and S2, the waves are going to be travelling the same distance from S1 to get to this point P on the screen as the waves travelling from S2 to point P. And point P you can see is exactly in the centre of the two sources. And it says the path difference, which we can label as S1P minus S2P, that's just the distance from here to here minus the distance from here to here, and that path difference between the two waves in this case will be 0, since point P is the same distance from each source. This is known as a central maximum or zero order maximum, since the waves will arrive in phase and constructively interfere. And another way of describing waves being in phase, remember, is to say that we have a crest meeting a crest or a trough meeting a trough. Moving on, it says now take point P to be shifted some distance along the screen from the centre as shown below. So this time point P is not directly in the middle between the two sources, it's been moved down the screen nearer source S2. So that means that the waves from source S2 are travelling a shorter distance to get to point P than the waves from source S1, and this means that the path difference, i.e. the difference between the distance travelled by both of these waves, is not going to be 0 this time. So it says the path difference S1P minus S2P between the two waves will be half a wavelength in this case, since the waves from S1 must travel an extra half a wavelength in distance than the waves from S2 to reach point P. So you see at this point the waves from S1 and S2 are overlapping such that we have a crest meeting a trough, which is going to be a point of destructive interference. That is, the waves are half a cycle out of phase. It says this is known as the zero order minimum, since the waves will arrive out of phase and destructively interfere. And this zero order minimum is the first minimum that will occur either side of the central maximum or zero order maximum. So you'll not just get this zero order minimum at this side, you would get it appearing on this other side as well. Now I'll just show you a quick simulation to help you visualise this. So just like we saw in the notes, here we have our two sources S1 and S2 and waves being produced from both of those, and we've got this point P exactly in the middle between the two sources or two slits here. So you'll see because the two waves travel the same distance to get to point P, the two waves will overlap constructively at point P, and therefore we get a central maximum or zero order maximum. So we have crest meeting crest or trough meeting trough at this point P. And we can label on the distances travelled by the two waves, and we can show that there's no path difference there. So both waves are travelling the same distance. However, if we think about point Q this time, you can see that the waves from source S2 are having to travel further to get to point Q than the waves from source S1. And you can also see that we have the crest of one wave meeting the trough of the other at point Q. So that means we have destructive interference going on, and this must be the minimum closest to the central maximum. And we can label this to show you the distances travelled by the two waves. So here we have a longer distance going from S2 to Q than we do from S1 to Q. And this green line is showing you the cut-off between where the two waves have the same distance in order to show you this extra distance travelled by the waves from S2. And we can label that here to show the small path difference. And lastly, we have point R up the top, which you might not be able to see on the screen, but here we have two waves overlapping constructively again, where we have crest meeting crest and trough meeting trough. And again, the waves from source S2 are having to travel even further this time to get to point R than the waves from source S1. So we can label that to show the difference in the distances travelled. So there's our difference there, which we can call the path difference. That's all for this video, folks. Thanks for watching. If you made it to the end, I really appreciate it. Make sure to give the video a thumbs up, subscribe to the channel, and I'll see you in the next one. Take care.